why is this important to calculate before you design a system? What give me some type of water heaters. Eric? What kind of water heaters can we have in the house? Direct versus direct. And those are using the heat coming from the boiler, or they can have their own heat source, gas or oil. What else? Brody. What about another type of water heaters? Heat pumps. You can use heat pumps to heat water. However, that can be very inefficient in cold climates, so it's not a very good one, but it is very possible. And we have a whole chapter last semester about water heaters and types of water heaters. Lance, what else for water heating? What other type of water heaters? So we said direct, indirect, heat pumps. What else?
Tankless.
Tankless. And tankless, how do they work? Good question.
Oh, no, I was gonna say I'm not.
On demand is the same as tankless. Or actually tankless should it's not always on demand. It's not the same. You can have a tankless that heat water right away from the boiler as it goes away with the coil.
Is tankless direct or indirect?
Tankless?
Yes.
I'll show you a tankless. This is a steam boiler, it could be hot water. And this will be your coil without a tank. So whenever you turn on the hot water faucet, water will come from here and it will heat right away to this coil. So water gonna come from this pipe, you go through the hot water, which is around like 200 degrees, and heat up right away. So this is tankless, and it's indirect because the water is not mixing. We're not taking water from the boiler. So this is one way to heat water through a coil. Okay? Let me see what else we can talk about. What is the temperature for water storage? Minimum?
120.
110, 120, 110. Any lower than that, you might have some bacterial growth. And what is the maximum that you want at the faucet? Like at the faucet, you want about 120. But when you store it, you want between 110 and 140 for the storage. You can go higher, of course. Why would you go higher? Jason? What would be a reason for you to have the water in your basement very, very hot?
Trying to eat something?
Huh?
Trying to eat something?
No. Think a little, Jason. But let's say if I have a tank in the basement and I have options of storing the water at 120 or 180. Why would I put 180?
Poison.
Give it a chance. Yeah, why? Why? What could be the reason?
Others could use hot water as well. At the same
Could
time.
be, what else?
If you're trying to get it higher up, like in
Yeah.
the building.
If there's more distance in the winter, if it's outside it's 0 and it's so cold, probably if you leave it at 140, it's not going to go hot all the way there. So in the winter, probably you'll go and adjust that a little bit. Or in the summertime, you can turn it down again. So it could be the distance, could be the insulation. In a very, very cold day, if you store the water at 140, by the time it gets to the second or third floor, it just doesn't get hot enough. Okay? What else? What would be the reasons of using, some of the advantages of using indirect? Instead of just using the water in the system and circulating the water. Let's see. Nathan?
Indirect,
But the waters are not mixing. Like you have a coil just like over here. coil going to the hot water.
Separate them.
Separate water and liquid, yeah, we don't wanna, and what else? You could use antifreeze if you have to. You have cleaner water that does not go through the boiler and get contaminated. Okay. Okay, that covers what we did last week. Okay, so, we're good? So we will try to finish up auxiliary water heating. I'll go through some examples for how do we calculate the requirement for hot water for a swimming pool or a spa, because it's good to know and it's very valuable information. So rating, when you want to go and buy a water heater, usually give you a rating, like how big you want to know, how big of a capacity is that tank. So there's something called continuous flow rate, which is GPM. This the first one? No, this is the most common one, but it's very old. It's not the most common. It used to be the most common, but it's very old. It's called the first hour rating. It's very complicated to understand what they mean by that. That's why they changed it to gallon per minute. So this is supposedly the amount of water you have stored at certain temperature and how long what kind of flow you will have to have an hour full of that hot water. If you can notice, it's a little bit like complicated to define. It's the gallons of hot water that can be produced from a fully heated water tank. So you heat the tank at 170, how many gallons of hot water can you get out of that? This means that the water heat can supply the amount of hot water at a given temperature for the duration of an hour. Of course, this depends on the heating element inside the tank and the capacity of heating and the incoming water here. So let me explain that for this for information. So if you have a tank and you have incoming water, and you have hot water coming out, and the water inside is 140, and you have either a heating coil or indirect here. So this is a 140 degrees, and this will give you hot at 110 degrees Fahrenheit, and the incoming is, let's say, 50 degrees Fahrenheit. So the first hour rating, it depends on the efficiency. How many hours can I get with 110 degrees Fahrenheit? Because this will depend on how much we can supplement the heat while we're taking some. So if this is coming at 50 degrees, and this is at 140, eventually the temperature here will be the average between them, which is 140 plus 50 over 2, that is 190 over 2, so 80 degrees. So this eventually will average out as we pull all the hot water and put cold water in there. The efficiency of how hot this heat element can make the water goes into the rating. So when they give you this tank can provide you with 120 or 110 degrees for 2 hours supply based on the incoming water averaging with whatever is in the tank. That's what they mean by the hot water, by the first hour rating. It gets a little bit confusing, but you get the idea. Cold water coming in, hot water is being stored. Eventually they will mix up, you run out of hot water. But if you have a good heating element, you keep adding heat to it, so you end up with something like 110 or 105 in the output. That's what they mean by the hot water first hour rating and how big the tank is. So if you want to supplement based on how much you pull out of that. That is the first hour rating. You might see that in some big tanks, usually for commercial buildings or multi-house buildings if you have a huge tank. Second rating is the continuous flow rate. which is GPM, gallon per minute, that's easier. So I'm not gonna think about the math or what's happening, what's going in and out. However, if you were to install a big tank in a commercial building or a multifamily home, you have to consider that, because you have 3 or 4 or 6 families living in the same building, different apartments, and one big water tank. So they want to know how much you can supply hot water for that building. If you have a small water tank, probably gonna go with the GPM, which is gallons per minute of certain temperature. Of course, it depends on the incoming water, so it's going to be a range. So in the winter, the incoming water usually is 60 or 50 degrees, so it's very cold. In the summertime, it will be different, between 70 and 80, so it's different. So this is the rating, that's more common. It provides the amount of hot water that can be supplied by the water heater in gallon per minute with continuous operation. So I turn the faucet, will guarantee you're gonna get 1 gallon per minute of hot water, depending on the flow rate of the faucet. Big faucet, probably is gonna be lower rating. Smaller faucet, you're gonna have more hot water. It also depends on the incoming water. Make sense? So for on demand, you want to make sure that you have the GPM, because you have no storage. First hour rating is when you have storage. You wanna see how much temperature can we have in that tank when we take it out. It will be great if we can heat the tank to 140 and not bring in any cold water, but it's not the case. To take out water, you have to bring in some water. Or if you can isolate that water tank, but it doesn't have happen. Usually it's going to mix in with what's incoming. Any question? Yeah.
It's different between heating coil and indirect heater, basically.
Yeah.
If we have like just inside something.
Yeah.
Pretty much.
If there is no heater, this is gonna be the average temperature. 80. After like probably half an hour, 1 hour, it's going to flow, you're gonna have 80. So if you have good heat source coming in to supplement that heat while you're moving, you will have probably more than 80. But the first hour rating, it tells you how much you can pull for how long. For an hour, you can get some hot water. But then after that, it's gone. But what contributes to that is the incoming water temperature and the heating coil.
Heating coil means electrical heat?
Could be
or
electrical, could be indirect, like this one,
Any type.
anything. Could be gas, whatever heat source you have in there. You're taking heat, you're bringing cold water, and you're also making heat inside the tank. We're good? Questions? Okay. How much do you need? This is a rough calculation. Probably you can also go and estimate based on new appliances. So for clothes washer is 25 gallons per wash. That's very conservative. And shower, usually 10 gallons. Again, that's very, very conservative based on the new ratings and new shower heads. 10 gallons, I think is enough. Less than that is enough. Some people have 40 gallons, depending on your rituals. But that's per person. So 25, 10, automatic dishwasher around 6 gallons. Again, very, very conservative. It could be more than that. Usually kitchen faucets is 2 gallons per minute. And keep it on, depending. Again, 2 gallons per minute for bathroom faucet. So on average, this what you will use around 64 gallons for a person if you do a wash every day, which is not always the case. And of course, communal living lowered that consumption because we consume a lot of water in the washer and laundry. So if you make a big wash, probably you save on the water. And also for dishwashing, if you use the dishwasher every day, probably that's 10 gallons of hot water. And again, you see the biggest consumption is the washer and the dishwasher, and some of those usually have their own heating element, so they do not need hot water supply. So it's a good incentive also to buy some of those new appliances. They have better pressure. Better pressure means less water consumption. Less water consumption means less hot water being used and less energy. So they have more energy efficient means. For the showers also, there's a lot of options. Shower heads can be changed. There are insulated pipes coming to the shower is another way to do it. Also, The water that you take to adjust the water inside the shower is also counted. If you're gonna wait a minute for the water to come in, that's kind of wasteful. So maybe it's better to put a on-demand hot water heater in the bathroom. Especially if you have a bathroom on the third floor, really far from the source. Maybe it's better to put a hot water tank inside that bathroom or on demand in that bathroom. So to calculate that per person, this table is in your book, so you can use that for your project. After we finish the heat loss, we can add this and see, based on the assumption. Remember the first time we assumed how many people living in that house? Is it 5, 10? Is it a communal house? Is it like seasonal? And how much are we going to use? So we can estimate how much is needed for that house. Shower, 10 gallons, again, it's very, very conservative. And we can add that up and see how much water we can use for that.
Can you go back for a second?
Yeah.
Okay, thank you.
Okay, and if you need more detailed information, I hope you still have your residential energy book. There's a whole chapter about hot water demand, how to calculate that. Again, if you get the new book, it will probably have more information, but they have more details about hot water demand. And if you look in chapter, here was I think this was chapter 2. So check it out. Also, if you go to the Department of Energy, they give you the new ratings, DOE.gov. They have new information about that. Okay, let's do swimming pools and spas. So you work for a company that does plumbing and HVAC, and they do new installs, new houses, and they want to heat the swimming pool or spa using a boiler. So we will talk about how to calculate the heat required for water. Again, there's a lot of general rules going on, but it's good to know how is it calculated. It will look more professional, put the numbers next to the swimming pool or the spa you are using. So, water heat capacity, we said water requires a lot of energy to heat, right? A lot of heat capacity to heat water. If you heat 1 gallon, or let's say half a gallon in a water kettle that has 1500 watts, it will take at least 3 minutes. It takes a lot of energy to heat water. Also takes a lot of time for the water to lose its heat. So, we'll talk about that, water heat capacity, and we also want to know about surface area. The bigger the pool, the more surface area you have, the more you will lose from the top. And that affects how much you lose, how much heat you lose from the surface, and you have to compensate for that while you're trying to heat the pool. So you're losing heat while you're adding heat at the same time. Okay? We're assuming also in those pools that the walls are insulated, relatively speaking. They should be a little bit insulated, so we are only concerned with the surface area to the outside. Is the pool or spa inside or outside? I mean indoor or outdoor? If it's outdoors and it's kind of windy and dry, probably you're gonna lose a lot of heat. The volume makes a big difference. And again, I would love to distinguish between volume and surface area. So let's make this clear. If I have this box, what is the surface area? This is the swimming pool.
Just the area.
Yeah, it's the top, yeah. It's going to be length,
Square.
length times width. That's the surface area. What is the volume? Yeah,
Cube.
times depth.
All three.
Yeah, because they're not going to be the same all the time. So you know the depth. So let's distinguish between that, and not all pools are square. People get really fancy about pools. So we'll talk about volume and surface areas, and all the formulas are in your book for you to use. We just need to understand how they work so you know how to apply them. And depth, another thing, depth usually is not constant. Bless you. You know, always they have deep end and shallow end, sometimes it's variable. So we would like to know what is the average depth. Do we understand the concept of average? Okay. So the average between three is sum of them, but kind of like this. You add the numbers, then you divide by the number of the number of the numbers that you added. So for example, let's I'll give you a small example about that. We'll see some more. So we go to this swimming pool, this deep end, then you have this deep end, and this deep end here. So this is, let's say, 15 feet. That's very good. This is 10 feet, and this is 6 feet. So I want to find the average depth. What would I do? I'll add all the numbers, average.
Divide by 3.
Yeah. 15 plus 10 plus 6 over 3. 25. So 25, 31 over 3. So that's 10.33.
Or the ends divided by 2, right?
But that's not going to be very accurate because you need, it's not consistent depth. It will be right if this was the case here.
So then it's 21 divided by 2.
Yeah.
21 divided by 2.
Yeah. You want to do
1.5.
without this one. But we have inconsistent depth. It goes in a step, it goes back. So again, it's not gonna be a very huge difference. What are you gonna do in real life? You can go with a meter and measure
So
that.
the more measurements divided by
Yeah, the number of
more
measurements.
accurate. So if you took 5 measurements,
Yeah.
divided by 5 would be
So it
better.
will be consistent.
Okay.
And that depends on the slope as well. Is
Mm.
it like consistent slope?
Mm.
Or is it like a little bit deeper, then it goes up, then a little bit deeper, so it will be a little bit different. So it's good to understand that. So going back with the shapes. So again, pools come in many shapes. Square, I get the area and I get the volume. So the area is the length square for square shape. And the volume in gallons is the area times the average depth. What is this number? Let's think a little bit. So this is foot square, and this is to, if I multiply this, I'm gonna get foot cube, right? If I want to convert foot cube to gallon, this is the conversion rate. Just to convert foot cube to gallons.
And that's the number.
Yeah,
That's always the same,
yeah,
7.48.
yeah. Again, consistency is very important when it comes to measurement. Inches and feet are not the same. Foot cube and gallons are the same. Oh, this is what the blessings of the imperial system. Everything is completely have no relation with each other. Like, so feet are 12 inches. A yard is 3 feet.
Yeah.
And a mile is how many feet?
5,280.
See, have no consistency whatsoever. Anyways, it's the only country in the world that use that.
Yeah, we're on.
So hopefully it will change at some point, but this is to convert between gallons and foot cube. Questions? Okay. Rectangle, length and width. And again, you're gonna go the same deal. Length and width times the average depth. Elliptical. This is another number, don't mistake that.
Oh, it's a little different.
Yeah, that's for the area.
Oh,
That's not.
for the area.
Yeah.
So that's why they call the machine the elliptical?
A times
That goes
B
in that motion.
times
Yeah.
the elliptical.
Look that. Circle.
Elliptical factor.
So this number is, if you notice, this number is pi over 2.
Oh, yeah.
Is it? I think so. Yeah.
No.
Pi over 2.
Over 4.
Which is 3 point, huh? Over
Over
4,
four.
yeah. Because it's pi r square. So pi r square is gonna be r over 2, so pi over 4 millimeters. You're right. Which is 3 point. Yep. This is pi, because again, if you look at the circle here, it's pi r square. R is the radius, which is d over 2. 2 square is 4, so this is this number. Circle, elliptical. It's in the book. It's open book. At least you know where it come from. And these are the most common shapes, and I have some more. Oval. It gets a little bit involved. So again, pi over 4 times d square, 0.785 times d square, plus the length times depth to get the oval area. Again, it's giving you the area, and for the volume, we multiply the area by the average depth. What about kidney? Kidney shape is very common. I don't know who came up with this idea, but somehow it became very popular to have a kidney shaped pool. I don't know, maybe Tracy will know what the history behind
You
that.
put like a little plant or something in the little hole there in the middle or something, nice.
Maybe.
A waterfall
Anyway,
maybe.
it's very common shape. I think it looks nice. I have no idea why would anybody do that. Just like, yeah.
I've seen it where the kidney is there and they have a hot tub in that little crevice
There you go.
Yeah.
built in.
So why not, man? If it's there,
Hot tub.
people wants to use that. And this is an approximation of how much this surface area is, because very difficult to estimate this area. So it's 0.45 times the length times A plus B, which is the small n and the large n.
Bet they just can't set a sonic thing in the center and press a button and then pull it out and go. That's what the gallons are. It hits the wall, come back, and it tells you exactly how many.
I'm sure there is something like that. But that's more work than me putting it in a paper in 2 seconds.
So every time you have a different shape, you have a different factor.
No, different, yeah, you're gonna have different volume. I'm trying to calculate the volume. This is what I'm heating the water, right? Calculate the volume and the surface area. I need the surface area because the surface area will tell me how much heat I'm losing, and the volume will tell me how much heat I need to put in. We're good? You can look those up. Did you find them in the book? Yeah, question.
I don't get the A plus B part, like which would you?
This is the A, the length between this end. So you'll go and measure it.
A plus
And this is the B.
So it's
two
for each
plus
end.
two.
So you can, first, this is the length. So 0.45 times the length times the total of A plus B.
Which is each side.
Yeah.
Okay.
And if you find another shape, look up the area and the volume. Maybe triangular, maybe hexagonal, who knows?
There's more shapes for pools than these?
Huh?
There's more shapes for pools than these?
Yeah.
It could go from a kidney to an oval, and then you'd have to
Yeah.
figure the both.
You can always ballpark it up. You can always divide it into small areas and add them together. Get creative with calculating the
Some of them
surface area.
nowadays have one of those lap things with the water that goes through.
Okay, average depth again. If I have a consistent slope, I'm gonna get the shallow end, the deep end, and divide them by 2. Misshapen one, try to get as many depth as you can, or find the where it changes and get the average depth. Sometimes it's not even like consistent, it's kind of wavy. So as Tracy said, go and take as many measurements as you can within each like foot or something, or 2 feet. Add those numbers together, divide them by the number of numbers. Number of data, which is the data you got.
Okay, the measurement D2
Yeah.
could be deeper, could be less deep, you know?
Yeah, could be either one.
Because it's like steps there.
Yeah, yeah.
What's the right measurement?
You gotta take this one, and whatever you measured here, whatever you measured here,
But we have another one,
Yeah.
right? Right
Yeah, over
in the
here.
middle.
you can measure here and here. That's gonna be given to this one, and you can measure also this big one. You can go from here to here to here to here, and divide by 4. Yeah. Okay? So this is to explain to you how much energy has to be put in that pool. Do not get discouraged by that. I just want to explain to you the energy that's been supplied. So the energy to supply the pool with heat is going to be the heat that is being put into the water plus the heat you're losing from the surface area. So let's say we're heating this pool. So you're putting heat in, but you're also losing heat as you go. So we have these dimensions. We're trying to heat the pool from 50 to 75. And the wind conditions is moderate. The volume of the pool in gallon can be calculated, so I need to know how much heat would I put into the pool and how much I'm losing as I'm heating. So first thing I did is I will calculate the volume, which is rectangular in this case, 30 times 20 times 6 feet as an average. It's the average depth. And this is the conversion from gallon to feet. And this is the number of gallons I got for that pool. That's the first tip you want to do always. Get the volume of that pool. The heat required to heat the pool can be calculated as number of gallons times 8.34, which is the heat capacity of water. This is a constant number. How much heat is required to heat 1 pound of water submerged. And this is the temperature difference. And this is the heat capacity of water. Actually, so it's the conversion between pounds of water to gallons. Okay. And this is doing this equation, I got the number of BTUs required to heat that pool. It's 25 million BTUs. So that's a lot of energy. Question?
So the equation right there, QSP equals QH QS. The answer you got 25,000.
That's the Q.
That's just only QE.
Yeah. That's what I need to put into that pool to heat it. So let's see how much. So 25 million to 9,488. So that will require us to have 183 gallons of diesel to heat that pool. 185. That's reasonable for this size pool. And bear in mind, once you heat it, it's gonna stay hot. If you heat it, it's gonna stay hot for a long, long time. This is a good way also to store heat. You know, I told you about some big buildings. They heat the pool or a big tank underneath underground. And they keep it hot for the entire winter season. You can make a cavern underground and just heat the water and just keep it hot for the entire season. So you can recycle that heat. People are getting very creative with using the pool heat. So we have a big pool. We're gonna use that for heat in the summertime. In the winter, we can recycle that heat into the house. And
Or
heat it.
into the hotel?
Yeah, you could. They do that. Very different kind of scheme. So it's good to think about this number and how much volume is put into the pool. So now, if I want to calculate how much I need to heat that pool, if I want to do it in 24 hours times a factor, how much heat I have to put in, I'm going to divide by the number of hours. So this is how much I need to supply each hour to take a day to heat that pool. So this is for the wind factor, just to show an example. This is how much wind is taken from the surface. And I'm gonna calculate the QS, which is the wind factor times temperature difference between inside and outside and the surface area. So doing this calculation, you're losing 30,000 BTU hour BTUs every hour from the surface. Meanwhile, I'm trying to supply this much. So I have to add this heat per hour to this heat per hour to get whatever heat I have to put in. Because as I'm putting 250,000 of BTUs, I'm losing 300,000, and this is what you get out of those two. So eventually I have to add 2,064 264,000 BTU per hour to heat that pool in 24 hours. A lot of numbers, a lot of crap, you don't need to know that. But, so I did it all for you. So I spent some time making this table for you, so you don't have to do the math. So this took me a lot of time. Right here, I did this number.
This never been done before?
Yes, I did that before, but I did it differently. So now, it's gonna give you like, how can I say, sliding ruler to know how long will it take you, how much energy you need to put into a tank. So please just read the fine print. But outdoor pool, water heating requirement in hours, giving the time that you need to heat the pool with, assuming 3.5 miles per hour wind, and target water temperature at 80, which is mostly what people want to heat the pool to, is 80. And pool average depth is 5.5 feet. I had to keep these things constant to be able to vary the other things. And this will go with the ambient temperature, 40, 50, 60, 70, and so on. So if it's 70, probably you don't need that much to heat it. If it's more than 70, you don't need to heat the pool. And if it's less than 40, you don't want to be in the pool anyway. It's freezing outside. So 40 to 70 is a reasonable temperature difference. The water volume, so you have to go and calculate the water volume. So based on the volume, we can go and interpret the surface area, and this will be the heating requirement, how much BTU you have to put in per hour to heat that pool in 48 hours. And if we go here, it's 36 hours, 24 hours, and 12 hours. So if you, this table is in your book, you can try to understand how does it work. 12 hours at a time, 24, 36, 48, and these are the temperature difference. And the only thing you have to calculate is the pool volume. That's very reasonable, right? And you look up the numbers. Look at the gallons, all the 50,000 gallons. Any more than that, you have to do your own math. So it gives you kind of a general rule to do that. So let's say, any question about how to use that? If you give it a closer look, it's not that complicated. The only thing you have to calculate is the volume, which is surface area times average depth. And just choose between. What if you get like a temperature between is 65? What are you gonna do?
Average.
Yeah, in between. Again, we're talking about thousands of BTUs hours here. Like one or 2,000 is difference, not gonna make a big deal. Okay, we're not heating a nuclear reactor; it's a swimming pool. But at least it'll give you an idea how much heat you have to put in there, so you don't put a very small, tiny boiler and you don't get the heat. And the owner wants the heat to the pool to heat in 12 hours. I've seen in Florida a lot of people frustrated in those compounds where they install a heater and the installer tells them, yeah, this will heat the pool in 12 hours. Actually, this actually happened to me. We went to a place and they said, okay, should heat in 12 hours. It took the whole weekend, didn't heat up because of their own estimation. So what is the use if you're gonna spend a lot of thousands of dollars doing making a pool and you can't even use it? So it's good to know how does it work. And again, the installation of a big boiler, that costs a lot of money. So let's say now we heated the pool. We want to maintain the heat. So again, wind is calm between 3.5 miles. You don't want to be in an outside pool on a windy day. I don't think that's pleasant, unless it's your thing. And now we're going with the surface area. And what is the ambient temperature? From 40 to 70. How much will we need to keep that pool hot? And this is the wind factor. If you have less than 3.5, then you multiply whatever you got here by 0.75, which is a little bit less. Between 3.5 and 5, you multiply by 1.25 in here. Between more than 10 miles per hour, you're gonna multiply by 2. And again, this is a ballpark, and it should like kind of give you an estimation of how much heat you need. Okay, I think there's a couple of questions in the homework regarding pool and pool heating. I don't think I will do that in the quiz. Maybe I'll ask you about, I'll give you the volumes, and I'll ask you to look up surface area. I really need you to know what's the difference between the surface area and volume. And again, it's open book, so you can look up stuff. Indoor is different. Some stuff goes into it, like heating time requirement, and keeping the inside around 70, and also relative humidity. You don't want the pool to humidify the entire location. If you go to indoor pools like the YMCA or some gyms, they have to think about that a lot because the pool is going to evaporate, and if the water gets saturated, it's not very comfortable. And again, this time I'm going to go with the surface area and volume. Again, assuming 5.5 depth, and the time required to heat the pool, then how much is to maintain it. Let's say it's a brand new pool, you want to heat it from what temperature? From 70 to 80, because it's indoor, so only 10 degrees. And how much is required to maintain that? What do you think? Look up.
That's awesome, thank you.
And you can always have this with you, and at least you understand now how does it function. Spas, 105 usually, much hotter, with bubbles. How much will it require for you to heat that for those hot spots? And that's why you will understand why some jacuzzis, I think jacuzzi is a brand name, right? It's not a hot spot. So hot tubs usually they vary in price between like, I don't know, anywhere but one. So the ones in the infomercials though. But they can be very expensive and very inexpensive depending on how much heat they put out and what is the heating coil. And again, if you use them, you're gonna heat it. Usually, if you heat it, you're gonna keep it a little bit warm. But if it's outside, it's gonna cool off. So every time you use it, you're gonna have to heat it. And you want to turn it on an hour before you use it. And it's not that big. Basically, the volume is not that huge. So this is how much power you have to put into it to heat it. And again, you can heat it with a heating coil or with gas. So what you need to think about is the pool outdoor or indoor? Temperature requirement, how hot do you want the pool? Time to heat the pool, and how to use those tables. Use a ruler, volume, surface area, time, and find out how much is the heat requirement. It will make things a little bit easier to guess instead of looking at the pool and say, yeah, you will need 3 gallons per hour. It's good to have a number to that. Again, at the end, it adds up to a lot of piping and a lot of heating requirement. Any questions? We're good?